Alright, so today what we're going to do is we're going to look at exponential decay. And before we go on to decay, let's talk a little bit about growth and decay. We just covered growth. So what were some things that we discussed that dealt with exponential growth, like real life situations? What? Stock market, yep. Stocks. I put a little money in my stock market and then all of a sudden it, boom, takes off, right? Yes?
Deposited in the bank?
Yeah, bank account, and it depends on how you invest it, but
So
yes.
Money.
Things with money. Yeah.
Population
Of?
of a town?
Okay, so yeah, we could do population. And when we talk about that, we can say people, because if you have a town that starts off and all of a sudden we've got buildings that are popping up, it's all of a sudden huge, Lakeville is a lot like that. Farmington's a lot like that. It's starting to become more and more popular in Minnesota. Shakopee, Jordan, all those verbs of the Minneapolis area, they're just taking off, aren't they? Yeah. There's also population of animals. Okay, we talked about rabbits before, but it could be mice, dogs, cats, anything where you could have multiple births, right? So you've got two rabbits, and then those rabbits have babies, and then those babies have babies, and then all of a sudden you've got a pet population, right? That could be a problem. Another thing that you can talk about is like a car. Okay, a Model T car fixed up right could be worth some money. Yeah, it could be an antique, and so you buy it, and it's kind of junky, not worth a lot, but you do it up really nice, and it's worth some money. Or snowmobile, or those antique-y type things. Could be worth a lot of money. Okay. All right, let's talk about decay. Let's talk about decay. What are some things that could start really high in value? Stocks. Also, they're still worth something,
just not as much.
But not as much. And you see that a lot, especially with high risk stocks. Yes.
Could it be like a house or something? Because like when you buy it, it's new, and then it's slowly like.
Yeah, absolutely. A home can, depending upon what you do with it, right? Yeah, if you live in it and you don't fix it up, it can go not very good. Yeah.
Cars, because like when you buy it new and you drive off, you're like.
Absolutely, yeah. Cars. You got a brand new Toyota Camry, you drive it off the lot, you get in an accident, boom. Yeah. Or even if you just drive it off the lot, it depreciates.
That happened to my grandma. She crashed her car 10 minutes after she got it.
That's tough.
I was
That's
also
tough.
gonna say gasoline, like prices on
Yes. Absolutely.
Oh,
Gasoline. Yeah. Yeah.
Could it population?
Population could be also, and why?
Because
Animals.
Well, it could be animals or people, but what's going on?
die.
Yeah, there's disease,
Or migration.
or war, or migration. Absolutely, yeah. People that are in a different land and they're not being treated fairly, yeah, they want to come to a different country, don't they? Now, will there ever be no people? No. But that's like smallpox, or polio, or rubella. At one time, it was killing a lot of people. So that's why we have inoculations. That's why we have the shots, right? Now, whooping cough,
Black flag.
black plague, all of those things were killing tons of people. And all of a sudden, it's like, boom, the population was going dramatically down. Yet we still had a population, didn't we? Anything that grows could decay, couldn't it? And that could be a problem. Because a lot of people are like, they get a new job, they're making all this money, it's doing great. Well, what happens if you get sick?
Buy our money.
Or, I know people that work on commission. Okay, so they have a job and they earn a basic salary, but they work on a commission. So the more washer and dryers they sell, the more money they make, and so they're like, oh, gravy train, I'm going to get a new house, I'm going to get a new boat, I'm going to get a new snowmobile, and then they don't sell as many anymore. So then what happens? They lose everything, and now we have to file bankruptcy, right? Yeah.
That's why you save your money, people.
That's why you got to save your money. That's right. That's right. So it's good to save for your rainy day, right? All right. Now, this looks a little bit familiar. If we did growth, we did the same type of thing. We made an H table. So I'm going to make an H table on the first function. And I'm going to make a function on the other, or I should say table on the other function. And when we did tables like this, all right, what numbers did we plug in?
-1, 0, 1.
-1, 0, and 1. Did we have to plug those in?
No.
No, but they tend to be just good, overall, easy numbers to use. So I'm going to plug in -1. Now, be careful on this, because 1/3 to the -1 power is
Don't you have to 3?
3. Because remember, we just flip our fraction. You could distribute and then flip, but you can just flip. Okay, 1/3 to the 0 power.
1.
Yes. And then 1. And most of you are just like writing it down. It's kind of fun in a weird sort of way because you know how to do it. It's just a matter of getting it down. All right, let's keep going. Notice that there are more steps to the blue. What's 2 times 1/3? 2/3. So again, we've done all of this before. It should be no surprise with doing it. The only thing is now when we graph it, some stuff is going to happen. Now, I don't have a graph on the slide, but you can easily make an X and Y axis and plot your points. I'm going to plug in a graph just because it's a little bit easier on here. It's pretty much exactly what we did yesterday, absolutely. Okay, so if I look at the black table that we just got done with, I had -1 and 3. I had 0 and 1, and I had 1 and 1/3. Now, what do you notice about that graph? It's going the other way, isn't it? Yeah, rather than it going up from left to right, it's going down from left to right. Now, will it ever cross the x-axis?
Yeah.
Never cross the x-axis. If it didn't for growth, it went for decay. Okay, and then we take the blue table and we're going to graph it. So I've got -1, 6, 1, 2, and then 1 and 2/3. Now, you'll notice that my black line really should go out a little bit more because you'll notice they shouldn't be on top of each other. Should be close. Then my blue was this. They shouldn't cross, and they should have arrows. Okay, now if I'm comparing on this, the blue line is on top of the black line, isn't it? So this is a vertical stretch. If you think of it, you're stretching, so you're reaching up, so it's going up. Questions? So if you did growth, this isn't hard. This is very similar to what you did before, it's just going the other way. Okay. Now, let's take a look at the next problem. The directions are tell whether the graph represents an exponential growth or decay, then write a rule for the function. Okay, so let's take a look at the graph.
Oh, that's great.
Okay, here's the graph. What we're going to do is, first of all, it goes up from left to right, so this would be a growth. And you can put the reason goes up from left to right. And you don't have to write it down on every single assignment. I'm just writing it because it's your notes, so you know why. Right now, it asks us to make an equation. If you remember, it needs to take the form y equals ab to the x. And we said a was our what? And we did the table.
X.
It was the value that was paired with the 0, right?
Yeah.
And it was called the what? You're thinking money. It's not the initial amount. It was on the table. Remember when we had a table and we circled it? And the x was 0, the y was a number. If I graphed it, it was your y-intercept. Okay? So let's look at the y-intercept here. What ordered pair is your y-intercept?
0, 4.
Oh, 0, 4. So I'm going to take this function now, y equals, and I'm going to plug in 4 for a. Now, do you remember back when we did slope-intercept form? And you remember when we had like ordered pairs like 0, 4, and like 1, 10, and we did y equals mx plus b, and we had to find the m, right?
Yeah.
With y2 minus y1 over x2 minus x1. Okay. How did we find the b if they didn't give it to us? Oh, we could take one of the ordered pairs and plug it in, couldn't we, to find our y-intercept? So if we didn't graph it, we had to plug numbers in. Okay, so this is what we're going to do. I gave you another ordered pair here. This is 1, 10. And they are the ordered pair x, y. So you're doing kind of the same thing you did with linear equations. It's just they're placed a little bit differently. So my y would be what? 10. So 10 equals 4 is my y-intercept. My b would be b, because I don't know what that is, and my x is 1 from my ordered pair, right? All right, so now what I'm going to do is do what? I need b by itself. I'm going to divide by 4 because there's multiplication there. So divide by 4. So b ends up giving me what? 10 divided by 4 is 2.5. Okay? So now my equation is y equals 4 parentheses 2.5 to the x. And that's my equation. Very similar to linear. The only difference is it's not a linear equation, it's an exponential equation, but it's the same kind of process. All right, let's look at the next one. Is this a growth or decay? This is a decay, and why? Goes down from left to right. And I'm still going to have my equation y equals a b to the x. Okay, I've got two ordered pairs here. This one is 0, 5. And this one is 1, 1. Do you notice, those ordered pairs that we went over and over and over again? That's the reason why we did it. We're using it now. Okay? So what do I plug in for my A? 5, because it's my y-intercept, right? It's paired with 0, so that's what I know, and I also looked at it, I know. Right? What do I plug in for my y now? 1 equals 5 b to the 1. What do I do? Divide by 5. B gives me, you gotta be careful. You can either do 1/5 or you can do 0.2. 0.2 is fine if it's terminating. But if it's like 1/3, that's like 3. So then you gotta be careful. So it depends on what your decimal is. So my equation then is y equals 5 parentheses 1/5 to the x. And that's your equation. Or you could put 0.2. Questions? So you see a lot of the stuff we did in linear kind of pops up in weird sort of ways, like things that we did in the past. H tables, we're using those again. Okay? Plugging in XY ordered pairs, we're using them again. Graphing, we're using that again. All this stuff we're using again. Okay? All right, one last thing I want to look at. All right, we're not going to look at the bottom exponential decay model today. I do want to take a look at exponential decay and growth. Notice that they're the same equations. Do you see that? And notice that my A, for our purposes, my y-intercept is going to be about 0 for right now. Sometimes it can be negative, but it will never cross the x-axis. But you'll notice the B. Do you see how the B in growth is bigger than 1? And do you see for decay, it's less than 1? Right? Take a look at this. If I look at this equation right here, this was growth, right?
Yeah.
What was my y-intercept? 4. What was my B?
2.5.
2.5. See how it's bigger than 1?
Yeah.
That's what makes it a growth, because it's bigger than 1. If I look at the decay, what was our B? 1.5 or 0.2 or 1/5, right? See how it's less than 1? That's what makes it a decay. So you can look at the equation and tell whether it's going to be a growth or decay. So when you're graphing it, if you get 1/5 for your B and it doesn't go down, you did something wrong. Okay? Questions? All right, that's it for today. We'll start our assignment.